All right, welcome back. For this video, we are going to finish the section 5.2 in the book, which is it started with integers. So if you're following along with the handouts, the first couple of pages were the integers. Now we're at the last page and a quarter or so is order of operations. So before we jump into the actual problems, just a little bit of discussion about order of operations. If you read my syllabus closely, you might have noticed that my second rule for my classroom is that you're not allowed to say you hate anything math related. Well, I'm going to break that rule in this video, and I'll explain why. So let's talk about order of operations. Okay, so when you hear the phrase order of operations, what comes to mind? Well, often what I hear, the most common answer here is PEMDAS. All right, and this is where I'm going to break my rule. I hate PEMDAS. Um, and the reason being, if PEMDAS has its uses, but if it was such a good tool for order of operations, why is it that all the time, like on the internet, you can see somebody post like this just basic math problem, like maybe 2 or 3 steps, and what's the answer? And be like a third of the people respond and say, well, I followed PEMDAS and I got this answer. And another third of the people will say, well, I followed PEMDAS and got this answer. So you're wrong. And then the other people are getting different answers. And, there's just all this back and forth. You've seen those, how the conversation generates. You know what I'm talking about. All right. So if all you know about order of operations is PEMDAS, you don't really know order of operations. All right. So I want to try to explain a little bit of this and hopefully make it a little bit more straightforward. Um, and just with everything that we're doing right now, we're reviewing this. The order of operation is definitely one of like the core concepts, because if you can't consistently follow order of operations, you can't consistently get correct answers. Which, by the way, the purpose of order of operations is not to get correct answers. That's more of a consequence of following order of operations. Something that took me a long time to realize, even as a math teacher, is order of operations. The purpose of it is really to tell us what order to read math in. Which you may think, well, we just read it from left to right. No, that's how we read our English. And very often there's parts of our math that we read from left to right, but that's not the overall order of operations. All right, so let's go over the actual steps. I like to refer to them as levels. All right, and so one of the questions I ask in class all the time we're covering this is how many steps or levels are there to order of operations? Generally, people, if they give me an answer, will say 6. Okay, well, why do they say 6? If you look at PEMDAS, there are 6 letters. All right, so there are not 6 steps or 6 levels of operations. There's only 4. Now, the other question I asked, another reason I don't like PEMDAS, is what does that P stand for? Well, the answer I hear here is parentheses. And so when people tell me that the P stands for parentheses, my next question is, well, what do we use parentheses for in math? Now, there are a variety of answers there, but by far the most common answer here to that is parentheses are for multiplication. So my next question is, why is multiplication in there twice? And why do we have multiplication here? Why do we have multiplication here? That doesn't really make sense. So that's part of the problem with these mnemonics, is sometimes they can be helpful, but if you don't know where the mnemonics came from, they kind of mislead you. So I really wish instead of PEMDAS, they would have been calling it GEMDAS. And the reason being is the first level, again, I like referring to them as levels instead of steps, is grouping symbols. So that's the first thing you do, is work inside all grouping symbols. And now, what is the most common grouping symbol? Well, yes, it is parentheses. So that's where the P comes from. It's not for multiplication though. It's the grouping symbol parentheses. But we have many other grouping symbols in math. The next most common that we tend to deal with or think of as a grouping symbol is the bracket. And so where do you see brackets? Well, typically you see parentheses inside brackets. And so they're really mathematically in terms of grouping symbols in order of operations, there is no difference between parentheses and brackets. It's really more of a typeset thing. Whereas, because if you only use parentheses, you sometimes might get lost in like which parentheses goes with which. But if you alternate between parentheses and brackets, it just makes it easier to read the problem. But we have a lot of other grouping symbols. If you've done your homework for the integers, you know what that is, absolute value. So that works as a grouping symbol. So you have to do everything inside that first. Something that we'll cover a little bit later. Square roots, cube roots, those kind of you work inside the root there. Top and bottom of fractions. Which, if you're not for sure what I mean there, if you look at sort of a messier problem, like that 56, 57, 58, what's your general approach to that? Well, you're going to work the top and bottom as separate problems. Right. So you're doing, the top of the fraction is a grouping symbol, bottom of fraction is a grouping symbol. We'll come back to that. Something else that you may not think of as a grouping symbol, each side of an equal sign. So when we get into the next chapter, we start solving equations, we're going to get into some messier ones. And then when we get to messy equations, you basically treat the left-hand side of the equation, the right-hand side of the equation as its own little math problem that we have to deal with before we actually start solving. And so the whole purpose of grouping symbols in math is to take these bigger problems, break them up into smaller chunks. So instead of like trying to read the whole book at once, now we're only trying to read like a chapter or a paragraph at once. So that is the first level in order of operations. Now, a phrase you might hear occasionally is called nesting parentheses. And I'm just going to use the symbol from parentheses rather than spell it out. And so, do you know what nesting parentheses are? Even if you don't know the name, pretty sure you know how to, in general, how to work them. So something like 49, that's a nested parentheses because you have parentheses inside a bracket. So nested parentheses in math are where you have grouping symbols inside grouping symbols. Another example of this, those Russian dolls, where if you open it up, there's a smaller doll on the inside. Open it up, there's another doll on the inside. Those are nested dolls. And so when you have nested parentheses, how do you work them? Work from the inside out. All right, so when you have those parentheses inside that bracket, those parentheses on the inside is where you start. Now, often what happens though is people will start working correctly, and then they'll end up just working from left to right, which we don't read math from left to right. We read math in terms of these operations. So to me, that's what the G or the P for PEMDAS. That's where you start. Is can we break this problem up into smaller groups? Okay. So what does that E stand for? Most everybody gets this. So this is exponents. And so for that E, we're basically just simplifying. And by that, I mean, if we have 3 to the 4th, we know that means 3 times itself 4 times. So we would write it out and actually change it to a multiplication problem. That's all there is with parentheses or exponents. Exponents are pretty straightforward, as long as you're paying attention to those parentheses and what the base is. Okay. Now, what's the next level? Well, if you say just multiplication, that's part of the problem with PEMDAS. It is multiplication and division. And the reason these are equally important, they're basically the same operation, just in reverse order. My example of that is, what is 15 divided by 3? Well, done enough know now that that's 5. Why is it 5? Because 15 divided by 3 is equivalent to saying that 3 times 5 is 15. So you can make any multiply problem, divide problem, and vice versa just by going in opposite order. So when do you know when to do which one? Well, if they're both in the problem at the same time, this is where you work left to right. So a good example of this, a good quick example of this. So if I have 8 divided by 2 times 4, and before I had this discussion, I'd probably get at least half my class to say that this answer would be 1. So they would look at that and say, well, you have to always multiply before you divide. So 2 times 4 is 8. And then do 8 divided by 8 is 1. That's incorrect because in this problem, the division is to the left of the multiplication. So the first thing you would do is 8 divided by 2 is 4, and then 4 times 4 is 16. If the multiplication was on the left, then we do the multiply first and the divide second. Okay, so that's the third one. And then the last level, and again, this is where people get in trouble. It's not add first, subtract second. It is add and subtract. They are equally important because, again, adding and subtracting are the same basic operation. Now, if you want to subtract a number, you could also say that's adding a negative number. Or if you want to think it on the number line, adding is when things are going in the same direction, subtracting things are going opposite direction, but you're still moving one direction or the other. Now, when you get down to this point, can you skip around? It depends. A lot of times people will look at a problem, and we did one of these with the integer addition where you had like 4 integers to add. If you're ignoring the negative signs, you're getting all sorts of trouble if you try to add first, because often adding is actually subtracting in that context. So again, this is where, to avoid mistakes, work left to right. Now notice there are 2 places where we say work to left or right. That's only if you're talking about multiply or divide or add or subtract. Add or subtract is always going to be a lower level than multiply or divide, unless in our grouping symbol, all we have is that subtract, so then it has to get done first. So these are like, once you're inside a grouping symbol, it's in this order. Now, quick question, and then we'll get into actual problems. I wonder if anybody can tell me why order of operations is in this order. I have a feeling you may have never been asked that before. So the grouping symbol, I think, is easy enough to explain. I think it makes sense that if you have a big problem, you want to break it up into smaller chunks if you can. So that's sort of, that purpose. But what about exponents, multiply, divide, and add, subtracting? Why are they in that order? Well, what is exponents? How do we simplify them? Well, exponents is just a shorthand for repeated multiplication. So when we deal with exponents, we actually break it down into a multiply problem. So exponents are basically a higher form of multiplication, okay, or division, depending on if you have negative exponents. We're not going to get that messy. All right. So why do we multiply and divide before we add subtract? Well, back to that early example of 3 times 5 is 15. How do we know that 3 times 5 is 15? Because at some point we learned that 3 times 5 means 5 plus 5 plus 5, or 3 plus 3 plus 3, 5 times, but multiplication is repeated addition. So multiplication is basically a higher form of addition, and you can think of division sort of as a higher form of subtraction. So we're doing the higher level operations first and breaking it down to the more basic. Is there anything more basic in math than adding, subtracting? That's basically just counting. And that's what we first learned to do in math is, 1, 2, 3, and so on. So that's why order of operations is the way it is to help us, take the more complex problem, break it down, piece by piece by piece. All right, and where the majority of the mistakes come in is, 1, violating order of operations, even though you think you're following PEMDAS, because you're always multiplying before you divide and not realizing that, those are equally important. Same with add subtract, that you always, don't always add first, just go from left to right. And then in bigger problems, people just ignore all this and start working left to right. Mistakes are made all the time with exponents. Mistakes are made all the time with negatives. And there's a lot of places that if you're not paying attention to detail, you can make mistakes. So one of the general things I'll say, and this will probably be the last thing before we get to the next problem, especially if you're a little bit rusty on this, please write down everything step by step by step. As you get more comfortable with this, then you can start combining steps. But I've seen it so many times that students, like the step where they make the mistake is the step they did in their head. So as I'm going through the notes, I'm going to show you how to systematically write this. And then you don't have to write it out all this way, but the messier the problem is, the more I like to write it out. And when you're taking one of my tests, I grade on partial credit. And if you don't show me any work, like if you just try to plug in your calculator all at once and you plug it in wrong and get a wrong answer, no work, no credit. So try to get in the habit with these order of operations of showing your work. All right, so let's get into some actual problems. Let's start with a basic one. Number 45. We've got 4 times 7 plus 19 times 11. So when I look at that, I know as students, you probably see the numbers. But one thing I've trained for order of operations, I've trained myself to do is order of operations. It's not order of numbers. So when I look at this, I see that there's a multiply, an addition, and a multiply. So of that, what's the highest priority? Well, multiply is higher order than addition. So we're going to do both multiplies before we do the addition. Okay. Does it really matter which multiplication we do first? Not really, because that plus sign is almost working like a grouping symbol. So do 4 times 7, which is 28. Bring down your plus sign, 19 times 11. And yes, I am grabbing the calculator. So that's 209. So we did both multiplications. Now you do the addition. So the final answer of 237. A very common wrong answer here, I would see people do 4 times 7, get 28, do 28 plus 19, and then take that answer, multiply it times 11. If you did that, you just violated order of operations. And when I talk about grading tests for partial credit, if you make arithmetic mistakes, like saying 4 times 7 is 27, maybe, that might be a point off. If you violate order of operations, that's a conceptual mistake, and that's like automatically at least half off the problem. Right, so violating order of operations is a bad thing. All right. So how about number 46? Let me alternate on these on paper here. It doesn't get messy. All right, so what do you do first here? Well, get in the habit of asking yourself, are there grouping symbols? That is one thing that you can use the GEMDAS, or if you insist, the PEMDAS. It's kind of use it as a checklist. Are there any grouping symbols? Well, yes. And the reason this prints is a grouping symbol, there's something to do inside. So one of the common mistakes here I see is people try to square the 5 and square the 9 or -9. The reason that's wrong is because you're trying to do exponents before you're dealing with your grouping symbol. But you have not worked that grouping symbol down to a single number yet. So the way I would write this, that 5 and that squared on the outside, we're not dealing with those yet. So I would just put those down because those are not changing. And now what's 5 minus 9? Well, if you've done your integer homework, you can go through it a little bit quicker. It's -4. And so now what do? Well, this is where a lot of times people will, again, revert back to left to right, and they'll do 5 times -4 is -20, and then they want to square it. Okay. If you did that, you just multiplied before you dealt with your exponents. So again, you violated order of operations. So now we have to do -4 squared first. By the way, why do we still have that parentheses? One, to help us with the negative sign, because that whole thing in there is getting squared. And also, that is 5 times whatever we get. And so you may want to put that multiplication dot there just as a reminder. Okay. So 5 times, now what is -4 squared? Hopefully you're saying positive 16 because that negative is inside the parentheses. So negative times negative is positive. And so once we do that, then we're down to the final step. That is 80. And so one of the advantages of writing it out step by step like this is if you make a mistake, it's easier to go back and find it. And I'll show you an even messier problem to kind of really put that home. And also like this, if it's on a test and you make a mistake, then it's easier for me to identify, where you're at. But you definitely got to be careful with your parentheses and your exponents as we've talked about. All right, so let's go back to without exponents. So the next one's 47. So we got 8 plus 16 divided by plus 16 divided by 4 times 5 minus 3. All right. Now, quick aside, are you allowed to do this on your calculator all at once? Well, technically, yes. But if you have to have your calculator and you're doing the whole thing in the calculator because you are, like let's say you're just getting back into this and you feel like you don't have a good understanding of it, so you just want to get your calculator and get done. Well, if you're letting the calculator do it, or Photomath, or AI, or anything like that, you're not learning, you're not improving your math skills. So when my recommendation on calculator usage when it comes to word operations, never put the whole problem in there at once. Rather, what you need to do is use the calculator for the small steps, right? Use your brain to do the big steps, let your calculator do sort of more of the grunt work sort of stuff. So on this problem, when I look at it, I see an addition, a division, a multiplication, a subtraction. Which one is the highest priority? Well, if you think multiplication, you're close, but you're still kind of in the old DOS way. So since division is to the left of the multiplication, we got to do the division first. Okay. And so what are we dividing? Well, the only thing we are dividing is 16 divided by 4. So the first thing I would do is write down everything else that does not change. We got 8 plus, and then times 5 minus 3. So for me, that really narrows the focus on exactly what it is that we're dealing. Okay, so 16 divided by 4 is 5. Okay. And now I treat every problem sort of like a reorganization. So now we look at it and say, what's the highest priority? We got an add, multiply, subtract. Multiply is the highest priority, so we multiply first. I bring down the 8 plus minus 3. 5 times 5 is 25. And now we're done with everything except by subtracting. So now I would go from left to right. 8 plus 25 is 33, minus 3, for a final answer of 30. If you're doing this and you get a decimal, it's most likely because you did 4 times 5 first is 20. And then when you did 16 divided by 20, you're getting a decimal or fraction, and then it gets messy. Okay. All right. Let's do 49 next. So 49 is 2 plus 7 bracket negative 6 plus 3 parentheses negative 6 plus 2 close parentheses close bracket. All right, so one thing I would definitely recommend is when you have that 7 outside the bracket or any number right next to a grouping symbol, that's going to mean multiplication. So that's 7 times that bracket, and it's also 3 times that parentheses. Now, before we jump into this problem, the question I'm going to ask to make you slow down is, what is the last operation that we're going to do? Not the first operation, but the last. Well, hopefully you're not saying anything inside the bracket because that's all grouping symbol. That's where we're going to start. And so the last thing, that's going to become one number. Then we're going to have 2 plus 7 times something. So that multiplication is going to override that addition. So that addition right there should be the very last step. And that's a common mistake, and we'll talk about it. So for this problem, this is what we're referring to as nested parentheses earlier. Where do we start? We start inside the parentheses, inside, and then work out. So I'm going to leave that 2 plus 7 times the bracket. Working inside the parentheses, so that minus 6 plus 3, it stays there. And so now, what is negative 6 plus 2? Negative 4. Okay. So now what do we do? Well, we got to keep working inside that bracket till we're done, or till we're down to a single number. So we have an addition and a multiplication. So we got to do the multiplication first. So bring down the negative 6. Now, when you're in these order of operation problems and you're multiplying and dividing, you have to kind of go back between saying add, subtract, or minus, positive, negative. So when I look at this, we're multiplying the 3 and the negative 4. So that's a positive 3 that we're multiplying times the negative 4. So positive 3 times negative 4 is negative 12. And so what we're going to write on the next line is negative 6 minus 12. So when you're talking about the multiplication, say positive, negative. We're talking about add, subtract, that converts down to add to plus or minus. Okay. Now we're getting close to the bracket. We're still working inside, so keep that 2 times 7. Negative 6 minus 12 is negative 18. Now notice I kept the bracket. At this point, a lot of people would go down to parentheses because we're down to a single number. This is why I say parentheses and brackets really are the same in order of operations. Doesn't matter if you write this, that would be the exact same thing as 2 plus 7 times negative 18 with the parentheses. Both of those mean the same exact thing. Okay. And so what do we do next? We have an addition and a multiplication. Multiplication is first. Now we're doing a positive 7 times a negative 18. Again, this number's a little bit messier, so feel free to grab your calculator. That's negative 126. So that's minus 126. And then 2 minus 126, bigger number's negative. That's a positive 2 and a negative, so we're subtracting. So that gives me 124. So the final answer is negative 124. All right, so here are the most common mistakes that I see on a problem like this. On the inside, if you made that negative 3 and did like negative 3 times negative 12, you added before you multiplied, so you violated order of operations. That's pretty common. The other common thing is I will see people do all the work inside here to get that negative 18, and then the next thing they'll do is do 2 plus 7. Because they're reverting right back, I think you kind of concentrate for a while, and then you maybe get a little tired or just lose focus a little bit. But now if you do 2 plus 7 is 9, you just added before you multiplied. So once again, you violated order of operations. Now, how you write this can either hurt or help the way you do the problem. I've seen students do this problem that looks something like this. Written down real quick, run out of room. So I've seen students do this. Basically, they'll just start crossing stuff out, put all the numbers up there. If you get the right answer, great. But what's the problem with that? Well, one, how easy is it to lose track of what you're actually doing? If you do make a mistake, what do you think your chances are of finding it if you're writing it like this versus writing it like this? Right. So paper is cheap compared to what you're spending for college, particularly when you do these order of operation problems. Take the time and space to write out your work. You're going to get more consistent right answers if you do that. All right. What are we going to do next? Let's jump to some fractions. All right, let's start with the basic one. Let's just start with 54. So what are you going to do there? We have 32 minus a negative 8 over negative 5. Well, we have to treat the top and bottom as a separate problem. There's nothing to do in the bottom, but what do we do with that top of 32 minus a negative 8? Well, I don't know about you, but when I've got that double negative on the parentheses, that's going to be 32 plus 8. And from there, it's a little bit much more straightforward. We have 40 over -5, and then that's -8. So not all these problems are going to be messy. And I've got the homework and the tests kind of set up the same way, where the more basic problems, the shorter problems are going to be at the beginning, and then you kind of work your way up to the messier problems. All right, so how about number 55? Did everybody notice those are actually absolute value symbols, not parentheses and not brackets? So there are a couple of those scattered out the homework, so watch out for that. And so word of operation, absolute value is a grouping symbol. So absolute value of 6, well, makes the number inside positive. So absolute value of 6 is 6. Now, absolute value of -6 plus 15, there's really a parentheses on the inside of that. So the first thing we got to do is, what is the, -6 plus 15? So that's 9. And now we apply the absolute value. So value of +9 is still +9. And now we got a straightforward problem. So that's 15 over 9. Now, anytime you have a fraction as an answer, you always have to check to see if you can simplify. Both of those are divisible by 3. So your answer will be 5/3. Don't go to mixed numbers with these order of operations. If they're not a whole number, we want a proper or improper fraction. Okay. So again, be careful. You will don't be surprised to see a couple absolute value problems in your order of operations. All right, let's do a little bit messier one. Okay. Well, let's do 57. So we have 50 parentheses 12 minus 9 minus 18 over 3 squared minus 3. All right, so question for you is, where do we start? Right. Well, the fraction breaks this up into two problems. We have the top of the fraction, the bottom of the fraction. Does it matter where we start? No, not really. I personally kind of like to start with the simpler one, and then do the messier one. It doesn't really matter. So when I look at that, I probably prefer to do the bottom first. Well, on the bottom, 3 squared minus 3. Well, we got to do our exponents first. 3 squared is 9. And 9 minus 3 is 6. So I do like all the bottom first, and then all the top. Some people like to do like one step on each. I think most people prefer to like pick a side and then stick with it until they're done. Okay, so now what do we do first in the top? Well, that parentheses is a grouping symbol because there's something to do on the inside. So the first thing we do is the 12 minus 9, which is 3. So we have 50, and that is times that. So 50 times 3 minus 18. And so now what do we do first? Well, we got a multiplication and a subtraction. Multiplication is a higher priority. So we do 50 times 3, which is 150, minus 18. Right? And then we do, continue on the top, do the subtraction. So that's 132 over 6. All right, so now we have simplified the top and bottom as much as we can. Now you could try to simplify that as a fraction. In this case, since the denominator is that much smaller, go ahead right quick and just do 132 divided by 6, see if it's a whole number. So that we don't have to deal with fractions. In this case, it is. So we're done. All right. Now, if you need your calculator on some of this, again, that's fine. But again, if you try to put this in your calculator all at once, it's highly likely, especially if you're order of operations, it's highly likely that you're going to put it in wrong. So what I want to see is you using the calculator something like, 3 squared minus 3, 3 squared minus 3. Now notice that the cursor is still up in the top. And if you back arrow, I can delete. How do we get that cursor where it needs to be? over arrow or down arrow. Now you got a big cursor. So use the calculator for the smaller chunks. Don't use the calculator for the whole thing at once. This is also how you can show work on the test if you're using your calculator order of operations, is do a little bit of time, put the answer, do it that way. All right. Let's do one more on this page. And I'm gonna see if there's any in the homework that we should probably go over. So 58 is 16 parentheses, -1, minus parentheses, -7, parentheses, -9, over 2 bracket -16 divided by -4 minus 4. Right. So this is, the longer these order of operation problems are, the more it is, can you consistently pay attention to detail? So let's just start on the top. So on the top, what do we have? We have a multiplication, we have a subtraction, and we have a multiplication. So what comes first? Multiplies are higher orders than subtraction. So we need to do 16 times -1. And then we're going to subtract -7 or times -9. So 16 times -1, that is a -16. -7 times -9, well, negative times negative is a positive, and that's 63, so that would be minus a positive 63. So this negative, the subtraction, which it just comes down, and then the positive negatives came out to whatever they came out to. All right, now we do have a double negative. So what I would do there is, the opposite of a positive 63 is a negative 63. So that really means -16 minus 63. Now, what do we do? Those are both negative, so we're going to add them. 16 plus 63 is 79. And is negative because the bigger number is negative. All right, so after all that, the numerator simplifies to -79. So now we do the bottom. So what do we do first in that denominator? Well, we have a bracket, so we're going to start there. And then inside the bracket, we have a division and we have a grouping symbol. So that grouping symbol comes first. So the 2 and the -16 and divide by are not going to change yet, but -4 minus 4 is -8. And again, we really want those parentheses there because that's helping us read the negative sign. If we didn't put it there, is that like dividing or subtraction? That can get messy. All right, but now we're doing -16 divided by -8. So negative divided by negative is positive, and that is 2. It's our last number. So a lot of times people put a parentheses instead of a bracket, and now we're getting 2 times 2 is 4. So now the question is, are we simplifying? Well, I'm not for sure about the 79, but 4 is just 2 times 2. 79 is not even, so this will not simplify. And again, do not take it to a mixed number or a decimal, leave it in this form. Or, you have a negative divided by a positive, so talked about this. Either of these will be acceptable. All right. I would really like to ask those questions, but I might. All right, let's pull one from the homework, and I think we'll call this good. So in my homework set, this is from the Order of Operations homework, number 24. So your problem will be similar, have different numbers, but it's the same basic problem. So mine is 2 parentheses 3 minus 4 squared minus 4 parentheses 1 minus 2 cubed. And we're simplifying this. So where do we start? Well, those parentheses are grouping symbols, so there's something to do inside. We're going to do both of those first. So the 2 stays, the squared stay there, the -4 and the cubed are not changing at the moment. 3 minus 4 is -1. 1 minus 2 is also -1. And again, keep those parentheses because we have negative signs that we're dealing with, and 2, we haven't done the multiplication. All right, so we did the grouping symbols. So after grouping symbols is exponents. All right, again, do not multiply 2 times -1. Don't multiply that -4 times -1 because you're multiplying before exponents. So, and again, you might want to put that multiplication dot there to help. So bring down the 2, bring down the -4. What is -1 squared? Well, -1 times -1 is a +1. And then what is -1 cubed? Well, that is 3 -1s. So that is +1 times -1 or -1. Now we're starting to get down to a much less messy looking problem. But we still have to be careful because what operations we have? We have a multiply, we have a subtract, we have a multiply. So the multiplies come first. Now with this first one, straightforward, 2 times 1 is 2. What are we multiplying the second, though? Are we multiplying a +4 times -1 or a -4 times -1? Well, to make the problem more streamlined, my recommendation when you're doing a multiply in the middle of a word operation problem, cover up everything that's not involved in the multiplication. So when I look at that, yes, we could say that as subtracting 4 times something, but when we're multiplying, that's a -4 times a -1. Right, so negative times negative is positive. That would be 2 plus 4. If you didn't do it that way, and you just brought down the negative, then you're doing 4 times -1, which is -4. And then you have that double negative. And what does that double negative mean with that parentheses? That means 2 plus 4, which is, what we got here a little bit quicker. 4. And once we do the multiply, now we're just doing basic addition. It's 6. All right. So order of operations is important to what we do out the whole semester. Now we get into the logic stuff in chapter 2 and chapter 3, like the second half of test 2, first half of test 1. It's not as important because we're not dealing with numbers as much there. But just in general, order of operations in math is always important. All right, so this is something that you really want to focus on. If you, like I said, if you can't do order of operations, you can't do math. All right, so hopefully this helped. And as always, if you have any questions, let me know. Have a good evening.